ever wondered how machines make decisions? Imagine a scenario where a computer can systematically evaluate options just like a human would. Intrigued? Let's delve into the fascinating world of decision trees where algorithms mimic the human decision-making process. Ready to explore? This is ITG3 production on data structure and algorithm.
In a cornerstone in the world of machine learning and data analysis, originating from the groundbreaking efforts of Arthur Samuel and further refined by Ross Pinlan, decision trees have evolved from simple constructs to powerful models like ID3 and C4.5, revolutionizing pattern recognition and data analysis. But what exactly are decision trees? Think of them as structured roadmaps, comprising nodes and branches. Each node represents a decision based on specific features, guiding us through a recursive process of datasets splitting to uncover insights and conclusions about the data. Understanding the terminology is key, that each component shapes the tree's structure. Now, let's break it down! The root node. This initial node represents the entire datasets, serving as the starting point from which the tree branches out.
Splitting. The process involves dividing a node into two or more subnodes, each based on specific criteria or features.
Decision node. When a subnode further splits into additional subnodes, it becomes a decision node, guiding the tree's branching process. Leaf or terminal node. These are the endpoints of the tree branches, representing outcomes or prediction. They do not split further. Pruning. This technique involves refining the tree structure by removing unnecessary subnodes, enhancing clarity and efficiency. Information gain and gain impurity. These are the metrics used in deciding how to split nodes. Information gain measures the reduction in entropy or uncertainty after a dataset is split, while gain impurity quantifies the likelihood of an incorrect classification of a randomly chosen element if it were randomly classified according to the distribution of labels in the datasets. Let's keep this in mind as we delve deeper into the decision tree analysis. Now, let's get hands-on. Decision trees offer powerful techniques for both classification and regression tasks.
Classification. In the realm of decision tree, it is a process of categorizing data into a predefined classes or categorizing based on input features. At each node of the tree, a decision is made based on a feature, ultimately leading into a classification or a prediction at a leaf node. Here's our dataset containing various features like weather, temperature, wind condition, and gym availability, along with our decision to play volleyball, like yes or no. By the use of the model, it helps us to navigate the features to inform us about playing volleyball outside. Now, let's test our models with our test cases.
In decision tree classification model, to predict gym availability based on certain features such as weather condition, we can explain test cases by using these 10 test cases as example and how the decision tree would classify them. Here are the 10 test cases examples. Test case 1. According to The decision tree, since gym availability is available and the weather is sunny, weather temperature is hot, and the wind is weak. The prediction decision tree predicted that the decision is yes. Test case 2. The gym availability is unavailable and the weather is sunny. The weather temperature is hot and the wind is strong. The decision tree predicted the decision is no. Test case 3. Since the gym availability is available and the weather is cloudy and the weather temperature is hot and the wind is weak, the expected decision tree predicted that the decision is yes. Test case 4. As stated, the gym availability is available and the weather is rainy. The weather temperature is moderate and the wind is weak. The expected decision tree predicted that the decision is no. Test case 5. Based on the gym availability is available and the weather is rainy. The weather temperature is cool and the wind is weak, and the expected decision tree predicted that the decision is no. Test case 6. As indicated by the gym availability is available and the weather is rainy. The weather temperature is cool and the wind is strong. The expected decision tree predicted that the decision is no. Test case 7. The gym availability is unavailable and the weather is cloudy. The weather temperature is cool and the wind is strong. The expected decision tree predicted that the decision is no. Test case 8. As indicated by the gym availability is available and the weather is sunny. The weather temperature is moderate and the wind is weak. The expected decision tree predicted that the decision is yes. Test case 9. As stated, the gym availability is available and the weather is sunny. The weather temperature is cool and the wind is weak. The expected decision tree predicted that the decision is yes. Test cases 10. Since the gym availability is available and the weather is rainy, the weather temperature is moderate and the wind is weak. The expected decision tree predicted that the decision is no. By explaining test cases like this, we provide insights into how the decision tree model makes predictions. Based on different combinations of weather availability, it helps users understand the model behavior and its decision-making process. But how do we know if our decision tree friend is making the right choice? Let's explore the evaluation methods.
Data set splitting. We split data for training and testing, ensuring our friends learn and test separately for accuracy. Cross-validation. Employing k-folding cross-validation, we ensure our friends' decision-making is robust across various data subsets. Confusion matrix. By analyzing these matrix, we gauge our friends' proficiency in distinguishing outdoor play from gym use. With an accuracy of 100%, our decision tree showcases a knack of precise decision-making. But there's always room for improvement, aiming to minimize incorrect prediction and enhance precision for both options. Now, let's move on to our regression tree.
In the world of volleyball, predicting performance can be as challenging as spiking a ball over the net. The PE instructor has a secret weapon, the decision tree regression model. This model breaks down players' training into two key factors, time and frequency. Training less than twice a week for 10 hours or less, expect a 75% performance estimate. But wrap up to over twice a week for more than 10 hours, boom, 100% performance. With this roadmap to success, the PE instructor can tailor training programs maximizing each player's potential. So lace up those shoes, grab your gear, and get ready to spike your way to victory with the power of data-driven training. Because in the game of volleyball, every point counts.
In Decision Tree model, to predict frequency and length of players' training, it depicts the circumstances that the PE for estimating performance level. The instructor with Node 3, training duration 100%, Node 2, training duration 75%, and Road Node, training frequency. We can explain test cases using these 5 test cases examples and how the decision tree would classify them. Test case 1. According to decision tree, since the dataset has a frequency of 3 sessions and time of 8 hours and a performance of 75%, the expected performance is 75%. And the predicted decision is 75 minus 75, the absolute difference is 0. Test case 2. As stated in decision 3, since the dataset has a frequency of 4 sessions and time of 12 hours and a performance of 100%, the expected performance is 100% and the predicted decision is 100 minus 100. The absolute difference is 0. Test case 3. As indicated by the decision tree, since the dataset has a frequency of 1 session and a time of 7 hours and a performance of 70%, the expected performance is 75% as the predicted decision is 75 minus 70. The absolute difference is 5. Test case 4. The decision tree, since the dataset has a frequency of 2 sessions and time of 8 hours and a performance of 80%. The expected performance is 75% and the predicted decision is 75 minus 80. The absolute difference is 5. Test case 5. Since the decision tree, the dataset has a frequency of 3 sessions and time of 10 hours and a performance of 95%, the expected performance is 75%, and the predicted decision is 75 minus 95. The absolute difference is 20.
By explaining the test example, it could serve as a guide for the instructor when creating training plans that are specific to each athlete by testing them with the students in PE. The instructor can modify training schedule to maximize performance by knowing how training frequency and duration correspond to performance results. Furthermore, in situations where finer estimations are required, the instructor can obtain more data or subjects matters expert to further hone forecasts.
Let's take a closer look at how these trusty tools measure up in the game of performance prediction. With the use again of data splitting, adding an extra layer of reliability with k-fault and cross-validation. Confusion matrix, peeling back the layer to understand how well our algorithm categorizes decision between playing outside and hitting the gym. And who could forget pruning? Just like trimming excess branches of a tree, we're streamlining our model to prevent it from getting tangled up in unnecessary details and overfitting. Remember, it's not just about accuracy, it's about precision and reliability. We need our model to be sharp as our serve. Our regression model hits the mark with a 76 accuracy in forecasting performance outcome. Talk about hitting the sweet spot? Now that's what I call a winning strategy. With the decision tree algorithm as our playbook, there's no limit what we can achieve on and off the court.
As we conclude our exploration of decision trees, let's appreciate the profound impact in data analysis and machine learning. Like friendly guides, they illuminate pathways for scholars and professionals alike. By understanding their fundamentals and embracing their applications, we unlock their potential to tackle challenges with grace and precision. Let's continue nurturing our understanding as decision trees remain steadfast companion in our journey of enlightenment and discovery.